Perfect. Hey everyone, I'm Kathan, one of the co-founders of BugBase. With me is Naina Sharma, who currently is acting as a security engineer in Paytm. She is experienced with everything security, right, from web to mobile pen testing. Now she is on a side where she's protecting everything from a corporate side, but she has also worked at Safe Security, where she had conducted multiple testings for various clients of them, right? Nana, let me know if I'm wrong anywhere. But yeah,
Yeah.
she has a lot of experience in mobile and web vulnerability testing. And today in this webinar, she'll be going into mobile application security, and we have kept the entire webinar from like moderate to advanced, uh, you know, advance of the topics for this particular topic. And we'll be definitely sharing with you all the resources that would be probably be required, that have been talked about in the webinar. So over to you, Naina, and any questions come in, I'll keep a note of them, and I'll also try to answer some of them on the chat as well.
Sure. Thanks, Kathan, for the introduction. So, hi everyone. Good afternoon, and thank you for joining in on a Saturday today. And let's get started. So, the agenda for today is mobile application security, and we'll be mainly talking about Android application security over here. Okay, so starting with the structure of a mobile application. So let's say you download an application from Google Play Store on your device, and you see that there are some files which are being downloaded, and you just start the application and you're able to get it up and running. But what's happening in the background? In the background, there is a file called .apk file, which is getting downloaded into your device when you're installing an application on your device. And this .apk file contains many directories, which are of use to us when we are going to reverse engineer a mobile application. So let's talk about these directories a little bit. So the first directory here is a lib directory. Lib is basically a directory which contains all the libraries and dependencies which are included into the application. Then there's a rest directory. Rest is for resources. Assets is for adding the assets into the application, like the media files and all of this. And then we have a classes.dex directory, which is basically containing all of the source code of an application in a Dalvik executable format. And this Dalvik executable format is basically a MID format, which is made when an application is compiled into the device with the help of a Dalvik virtual machine, and it helps in executing the applications on a mobile device. Every application on a mobile device is basically containing its own Dalvik virtual machine, and this is specific for Android applications. Then we have the most important android.manifest.xml file, which is basically providing us with meta information and the most crucial information regarding the application. And this mainly contains all of the components and what are the permissions which are being used by the application, so on and so forth. We'll discuss this in detail in the further slides. Then we have meta inf, which is basically containing all of the meta information regarding the packages which are installed. And then we have resources.arse, which is basically containing all of the compiled resources of the application in a way that these resources are given a particular ID after getting compiled so that they can be invoked during development into the source code. So with those IDs, they can be invoked into the source code. So this is a very brief about the application structure. Moving forward, we have an image of the Android manifest.xml file. And as you can see over here, it's containing a lot of meta information regarding the application. So this snippet which we are looking at over here is basically a snippet which occurs when we reverse engineer this .apk file which I just mentioned. From reverse engineering, what I mean is that whenever we get an application, this .apk file is basically a package which is containing all of these directories which I mentioned before. Now, APK is packed. So in order to unpack it, we need some kind of reverse engineering tools. Like we have APK tool, we have JADEX. These are the most popular industry standard tools. So there is a difference in the level of compilation, in the level of, sorry, not compilation, in the level of reverse engineering which is taking place when we are working with JADEX and when we are working with APK tool. The following snippet is that of JADEX. So what it is doing is that whenever we are entering a particular APK into JADX, it's giving us a display of all of the entire source code of the application, the Java directories, the REST directory, the Gradle scripts, and manifest.xml file. So in the manifest.xml, we are able to see what are the permissions which are being asked by the application. Let's say it is asking for a find location permission or a network state permission. And we are also able to see what are the components of which this application has. For instance, we are able to see that there is a provider listed over here. There is an activity listed over here. And there is an intent filter set up for all of these activities. You don't have to worry about these details right now because I'm going to cover it in the later slides. What is the meaning of these components and what is the use of these permissions? But this is just a snippet which I wanted to show you guys so that you can understand that this is how it looks after reverse engineering. Moving forward, let's talk about the application components in quickly. So the four main components of the application are activities, services, content providers, and broadcast receivers. From components, I mean that these are the things with which the application is made. So let's talk about activities first. So let's take an example of a real world application called, let's say, Instagram. So on Instagram, whenever we are traversing through Instagram, we can see that there's a profile activity, there's an explore activity, there's an activity on which you can share, check your field, then there's an activity on which you can check your stories and things like that. So all of these are activities. Activity is nothing but a single screen of UI with which an end user can interact. Each activity in an application is completely isolated from each other, and different apps can invoke activities if permitted. So this is an important detail about an activity right here. That is, different apps can invoke an activity if permitted. So let's say we have this Instagram application on our device, and we have other applications also on the device. So every activity will have some kind of meta information which will be listed here in the manifest.xml file. And according to that meta information, we'll be able to identify that, let's say if we are able to install a malicious application on our device, and we also have an application which has some kind of exported component available, that means that we'll be able to call that activity through that malicious application which we have installed. We'll cover this detail further in the slide in with an even better explanation. But here's just a brief about activities. Moving forward with the services. So service is nothing but a background process which is running long operations. Let's say we were using Instagram, but now we also want to listen to music on our device. So what we'll do is that we'll put the Instagram application into the background. We'll put the Spotify application or any other application which you're using for playing music in foreground, and we'll just play a song. Now, after playing the song, I just don't want to keep traversing to the music application and I want to go back to my previous activity. So that can be done. I will again put Spotify in the background. I'll put the activity of Instagram in the foreground, and I'll be able to access Instagram. Now, what is a service over here? The music which I started. The music which I started will still keep running even if I am trying to use some other application. So that's a service. Services can be custom services and they can also be system services. Custom services are basically services which are provided by other applications, and system services are services which are provided by the system. Let's say you're downloading a file. So that's a system service. It'll keep downloading in the background. You can still use other applications. Then we have a content provider. A content provider is a shared set of application data. And this content provider is basically helping us store the data into our application. And there are different types of data which we can store. Let's say data can be stored in the form of SQLite databases. It can be stored in the form of flat files. It can be stored in the form of shared preferences. It can be stored in the form of cache also. So that's about content providers. And then we have a broadcast receiver. Broadcast receiver is basically used for alerts. The notifications which we are getting on a device, that is because of the broadcast receiver. And this broadcast receiver is also passing some data, and that data is directly visible in the notifications. So these are the four basic components which are used to form an application. Now, the common misconfigurations which are there in these components can be whether these components are exported or not. I mentioned the example of an activity which is exported early on. And then the setup of an improper intent filter. We're going to talk about this in detail. So moving forward, now we have spoken about brief of an Android application, how the components work, what is the use of a manifest.xml file, and what does an application contain. Now, if we want to perform a security assessment on a mobile application in a real world, what we do is that we divide the test cases into 7 major areas. Number 1 is storage. How is the data being stored? Where is the data being stored? Whether the data which is being stored needs to be stored or not. If the data is being stored, whether it is being stored in a secure manner or not. Whether all of the data which we are storing into the application is stored in the locations which we want to store it in, and there is no side channel data leakage through storage. Then, what is the cryptography being used? What kind of cryptography is being used? Whether we are using any deprecated algorithms or not, so on and so forth. Then we have auth, which is basically related to the authentication mechanisms which are being used in order to authenticate into the application. Then we have network. How is the data being transmitted across the network? How is the application communicating with other applications? How is the application communicating with the backend server? And whether the data is being transmitted in a secure manner or not. Then we have platform. Platform basically contains all the platform specific vulnerabilities. That is the vulnerabilities which we can get because of the system or the platform on which the application is hosted. In this case, it's going to be Android. So all of the test cases which are coming up because of the application which is being downloaded on an Android OS. And then resilience. Resilience is basically how resilient an application is in terms of the integrity, in terms of bypasses for platform specific checks like root detection and SSL pinning. So these are the 7 major areas of test cases, which we're going to talk about in detail. And we're going to cover multiple vulnerabilities which we can find across these test cases. So are there any questions regarding whatever we have covered until now?
So Naina, Hitesh is asking, which is the 7th major area, or are these only the 6 ones?
Right. The 7th major area here is basically privacy violation. So privacy violation is something which is mentioned as a 7th area in the MSCG, but we're not going to cover it right now because all of that privacy violation regarding the dependencies and regarding the users data, we are going to cover it into some other test cases within these 6 itself.
Got it. And Suresh is asking example of any platform vulnerabilities.
Right. We're going to cover those in the later slides. We're going to cover examples of all of the types of vulnerabilities in the later slides. Okay, Hitesh. Okay, moving forward, let's start with storage. So storage can be done in different ways in an Android application. As I mentioned, we can store data in SQLite databases. We can store it in shared preferences. We can store it in file permission. There are some file permissions. And we also can store in realm databases, which are basically real-time databases. So what I've done over here is that I have mentioned the path to all of these databases. And this path is something which you're going to get when you are connecting your APK through an Android debug bridge. And once you connect it through an Android debug bridge and you're able to get a sudo access on the device, you'll be able to traverse through the particular package name. So in the manifest.xml file, there is an inclusion of a package name for every application, and every application has a different package name. So once you get that package name and you're able to get sudo access on your ADB, you can traverse to the given package name. You can just mention the package name over here and get into the data directory to look at the SQLite databases. So what that will show you is the SQLite databases related to that package name. Now, whenever you are trying to check for any kind of vulnerabilities in the storage in an Android application, these are the few directories which you are supposed to look at. That is internal and external storage. There is an SQLite database, and there are also cached files. The content provider is being used to store data in all of these resources, and these are the permissions which these are the directories which you can use to check whether the storage has been done properly or not. Then in storage, there can also be some kind of side channel data leakage which was not intended, for example through logs. So again, after connecting through ADB, you can get the logcat command, and this is the command which you can use. In this also, you can mention the package name of the application over here. So any application which is installed on your device, you just need to know the package name, and you'll be able to grep the logs regarding that application. Once you're able to grab the logs regarding that application, you need to skim through those logs, and you need to check whether any kind of sensitive information is being disclosed through those logs. Then there is some data which is shared by third parties via embedded services. So there are a lot of applications which are actually performing tie-ups with multiple applications, and they are including those links within their applications. So we need to check all of the requests which are made to external services for embedded sensitive information, in order to ensure that any kind of sensitive information regarding to that particular user, whose application, the session of whose is going on within that application in which our third party embedded service has been added, we need to check whether the details of that particular user are not getting transmitted through those third party embedded services. Then talking about keyboard cache and input field, again in keyboard cache, we need to check whether for sensitive field, this particular input type, text no suggestions, has been enabled, so that the user will always have to type the suggestion manually, and it will not be stored by the system, in order to ensure that any kind of sensitive data regarding the, let's say, credit card information, regarding the passwords, is not auto completed by the device. And in order to auto complete it, it will have to store that data. So this is something which is not recommended for sensitive fields, specifically financial and card information. Then backup, again connecting through ADB, you can check the backup of a particular package name and see whether any sensitive data is being stored in the backup. And if that sensitive data is being stored, we need to check whether it's being stored in a correct format, let's say in an encrypted format, so that these files cannot be decrypted by anybody who's able to get the backup regarding that particular application. And then in order to check any kind of memory, in terms of, this is basically the stack and heap data, so we can perform a fry dump, and there is a tool called objection. So there are two tools which are very important over here, that is frida and objection. Frida and objection, both these tools are used for method hooking, something which I will touch upon in the later slides. And these tools are basically also giving us these particular commands in order to dump all of the system memory related content. And fry dump is also doing the same thing. So memory also we can skim through, and we can check that there is no sensitive data which is being stored over here. So these are like very small test cases which we want to cover for storage, in order to ensure that there is an overall coverage of not overall coverage of the security of the application in terms of multiple areas of test cases, so that we're not missing out on anything. So we have SQLite databases, shared preferences storing the value in storing the data in key value pairs. We have file permissions. File permissions we can check in the data directory as well. We'll touch upon this later as well. And the realm databases, which are basically the real-time databases. And then side channel data leakages, unintended data leakage, which is being done through logs or keyboard cache or backup or memory, etc. Moving forward, let's talk about crypto. So crypto, again, following test cases need to be looked into. First, we need to check the symmetric cryptography which is being used, such as algorithms such as AES and DES. And we need to ensure that all of the algorithms which are being used in symmetric cryptography are industry standard algorithms, and they're also using industry standard key and block sizes, and they're ensuring that the modes which are being used with that are also correct or are also according to the industry standard. All of this information you can get easily on the internet, and you need to ensure that no deprecated algorithms are being used, because the computation power of the computers has increased to such an extent that the complexity required to break these algorithms is getting minimized day on and day in and day out. So we need to ensure that the algorithms which are being used are correct. Then checking for the availability of java.util.random. This is a very common test case which is being used to in the in crypto checking for mobile applications, and this is called random number generation. So why this is important is because sometimes these java.util.random classes are being used to generate keys for encryption, or are being used to generate the initialization vector which is being used to utilize which is being used to perform encryption on particular sensitive data. So we need to ensure that java, instead of java.util.random, only a secure random class is being used, because a secure random class does not contain vulnerabilities like collisions, and we will ensure that any kind of initialization vector or any kind of sensitive key which is being generated will always be a new key rather than something which might have occurred before. So this is basically vulnerable to collision attacks. That's why we prevent the usage of java.util.random, so that no collision occurs in the future regarding the uh, unpredictable data generation. Then we have configuration of cryptographic standard algorithms. We need to check all of these details which I've mentioned over here. Like in classes, we need to check all of the cipher, MAC, message digest, and signature algorithms. So this also include not just encryption, but also hashing algorithms. So you need to ensure that all of the hashing algorithms which are being used are also the industry standard algorithms. Again, for signature, the implementation has been done properly. Interfaces, there is key, private key, secret key, functions, functions which are generating the key. You need to reverse engineer the source code through JADX and APK tool, and look into the source code for all of these classes, interfaces, and functions, and check, excuse me, whether the implementation has been done properly or not. And then we have functions. We also have some exceptions like key store exception and certificate exception. And we have a few classes which I've mentioned over here. Java, all of the classes which are using these packages, java.security, Java X Crypto, Android Security, Android Security Key Store. So you need to ensure that you are also, skimming through all of these classes after reverse engineering to ensure that the implementation has been done properly. So this was a little bit brief about what we look at after reverse engineering in crypto, and what we look at after reverse engineering in storage as well. Moving forward, okay, so here I want to mention one thing, that apart from the security which we are implementing on the API calls in the mobile application, we are basically covering all of those test cases which are specific to the platform over here. Let's say we are talking about mobile applications. So API calls and other test cases remain the same as that of webs in mobile also. But for example, in terms of auth, so there are also other test cases which we'll have for auth over here. But we are only covering platform specific right now in order to give you a more brief about what is the extra which we are doing in a mobile application security testing. So I'm looking a little bit of uh, chat over here. Are there any questions?
Yeah, I guess there are a couple of them starting from, you know, just give me a second. Yeah, so Krish is asking, he's not clear with the auth one. I'm
Mhm.
not sure about that. If probably you want more details. And then Bimal is asking, from your point of view, which vulnerability gets the most attention these days? Right.
From my point of view, which vulnerability gets the most attention these days?
Correct.
I would say misconfigurations in the components and misconfigurations in deep links, which is also something which we are going to touch up on in the later slides when we are talking about platform specific vulnerabilities. But deep links and misconfigurations in components for mobile applications are something which are getting a lot of vulnerabilities these days.
Got it. And Anup is asking, can you probably share brief details about external storage permission read and write? Right. This is what he has mentioned. So I'm guessing something around, yeah, external storage
Right.
permission and
So
read
for
and write.
external storage permissions, all of these permissions are listed in the Android manifest.xml file. And for read and write external storage, it is definitely not permitted for any application to do that, specifically for writing external storage. But in terms of the business use case, it is dependent on the application which we are talking about. So let's say any application has a business use case of reading and writing data in the external storage, then we can just provide an exception for that. But as a security engineer, we definitely do not recommend any developer to include this particular permission into their application.
Got it. And Chirag is asking, can you please share the mitigations for those bugs too? Like all the vulnerabilities that we have discussed. Will you be sharing the mitigations for them in this webinar?
Yeah, sure. A little bit about the mitigations also. But let's say whenever I discuss the case for crypto, I already mentioned that you need to, do your research regarding crypto, and you need to check what are the industry standard algorithms, what is the industry standard key size being used, industry standard mode being used. For example, I have mentioned AES over here. So with AES, we need to ensure that we are using AES 256 with a GCM, that is Galloway counter mode, and any kind of padding also which you are applying along with the implementation of encryption. You need to ensure that that is, industry standard padding like PKCS7. So these things are the mitigations for crypto. And for storage, I already mentioned that once you are able to get into, let's say, side channel data leakage we are talking about, and you're able to find any sensitive data which is being disclosed through side channel data leakage on logs, so you need to get back to your development team and you need to ask them to ensure that this particular variable is not getting included or not getting thrown in the logs. For keyboard cache, you need to ensure that there is this particular input type text no suggestions enabled for sensitive fields. You can't do that for all the fields, but for sensitive fields. So yeah, these are the mitigation obvious mitigations mentioned for these particular controls. But for other controls, I will mention the specific mitigation as well. For SQLite, for this local data storage, you need to ensure that if any sensitive data is being stored, I am time and again emphasizing on the word sensitive, because the applications are also required to store other kinds of data which they will further on use whenever the user is restarting their session in the device. So that kind of data is not important, but you'll have to skim through a lot of data, a lot of databases in order to find out that just that one sensitive key value pair. And once you're able to find that, you need to ask your teams to ensure that this data is either not stored, or and if it is stored, then it is stored in an encrypted format, so that anybody who's able to look at this particular data, let's say your device gets stolen or lost, then they'll be able to get anybody who is skilled enough to skim through this particular process, they'll be able to find out that this is the data or the session data regarding this particular user session, and then they'll be able to make use of it in inexplicable terms. So this is about the mitigation for storage and crypto. Other mitigations I'll keep on speaking about when I move forward with the slides.
Got it. Do you want to move ahead, or there's one question that probably we can answer now, and then we
Sure.
can answer the questions later. So Kamal is asking how to check storage related issues using ADB if I am using a non-rooted physical mobile for testing.
Okay, I think for a non-rooted device also you can connect to ADB. right? But you'll have to, I think, only after sudo access you are able to get into the data directory. If you are able to get into data directory, even with a non-rooted device, then you'll be able to see regarding the package name, because package name is something which you can get through manifest.xml. Just take the package name from manifest.xml and get into the ADB shell. Let me know if you have shell access or not. If you have shell access, then you will be able to get into the data directory and check. If you don't have shell access, then you'll probably need a rooted device.
Perfect. Yeah, I guess you can continue with the webinar. What I'll do is there's one more question. I'll keep it for now, and we can answer it later probably.
Sure, sure. Okay, so moving forward with auth controls, auth stands for authentication. So in auth, let's say we're just looking at two very small controls, but the bypasses are very interesting over here. For example, biometric authentication check. So a lot of applications are working on a biometric authentication check, specifically financial applications, because the financial data is something which we need to secure at multiple points. But the interesting thing about it is that now in an open source way, scripts to bypass this fingerprint or biometric authentication are also available. And the link to those scripts is again mentioned over here in the fingerprint bypass and fingerprint bypass via exception handling. So what these scripts are basically doing is that this is a Frida script. Frida is again a tool which is used for method hooking. So method hooking is basically a concept in which once we have reverse engineered the application and we are looking at multiple classes, these classes are made up of methods or functions. And these functions are returning some kind of value. So if at runtime, we are able to hook to those particular functions and the application is running, we are hooking to those functions and we are performing an activity which is invoking that particular function in the application. If that particular function is being invoked and we have performed some kind of hooking and we have ensured that on real time, the value which that function was supposed to return can be changed or modified into the value which we wanted to return now through this method hooking, then at runtime, the return value can change and it can lead to a display of completely different data. How we can do this is with the help of scripts which are written through JavaScript. And how after writing the script, this particular script, how we are writing it by looking at the source code which is there at the backend. After looking at the source code, we are hooking to those particular methods which we want to hook to, and we are mentioning that okay, this is the variable which we want to modify at runtime. And once we have done that, we set up a Frida server on our mobile device. This is basically a rooted device which we have with us, and we also have a Frida setup on our laptop device from which we'll be injecting the script. We'll call that particular package name of the application, and then specify which class and which method in that particular package name we want to hook to through the Frida script. There are few commands which we use to do that. The data is again openly available in frida.codeshare.com. So you can go ahead and check that also. And once we are able to, perform this entire setup, we'll just run the script and we'll be able to see that the objective which we wanted to achieve by hooking that particular method has been achieved. So in this biometric authentication check, this is a similar thing which we are doing. We have created a Frida script for fingerprint bypass, and to bypass the authentication when this particular crypto object is not used in the authenticate method of the biometric prompt class are available openly. The authentication implementation relies on the callback of on authentication succeeded being called. So on authentication succeeded is basically the name of the method which is being used to check whether the authentication has been succeeded or not for this biometric authentication. So we'll just call this method and it will return a true or false value, either true or false, whether the authentication is succeeded or not. So at runtime, if authentication is not succeeded, it will return false. But if we wanted to bypass the authentication, we'll have to ensure that it only returns true, even though we have not authenticated into the application. And once we are able to do that, we'll be able to bypass the authentication over here. Same is the case with fingerprint bypass via exception handling. This is also considering the crypto object exception handling, and it is mentioned in the blog post, which is again linked over here. Okay, so this is a biometric authentication check which I wanted to include here because this is a relatively new check which has come up. This was not available a few years back, but it's an interesting thing to do. So, right, a few years back, we were only using FRIDA strips to bypass, let's say, root detection or SSL pinning and all of the resilience controls. But here, we can also use it for auth. We have a few questions in the chat regarding this. I think we should cover these. Okay. Riaz is asking that, is there a way to bypass PIN other than brute forcing? PIN for the mobile application, right? Yeah, you can, what you can do is that you can again create a script. You can reverse engineer the app, check which class or function is actually checking whether the PIN which has been entered is correct or not, right? And if you can see that the value which it is returning is either a boolean is a boolean value, then you can maybe try creating a script, and there'll be a lot of what can I say, you'll have to work a lot on the script. Like sometimes it will work, sometimes it will not work. So you'll have to ensure that all of the methods and all of the classes which you have mentioned are correct, and you have also included all the methods which are working for the authentication of that pin. And once you are able to do that, you can perform a hooking on that application, enter a random pin, and check whether it is able to get you in or not. So yeah, you can do that through Frida. Mm,
Sorry,
for
Nana,
example,
you answering all the questions. So,
yeah.
I had my net weakened out. So, did I missed out on something? Do you need any help?
Yeah, I was just trying to answer a few questions.
Okay,
For
okay.
example, we have pin on Paytm app. Yeah, yes, Riaz, I understood. So yeah, my response remains the same. It depends on how the source code of the application is written and whether you are able to find out all the functions which are involved in checking the authentication mechanism of that particular application. Okay, Chirag is also answered question. Hi, ma'am. Do you have any methodology or checklist which we can follow for our Android pen test or bug hunt? Yeah. Yes, Naman. I do have a methodology and checklist. And as I mentioned towards the beginning of this presentation, that I have actually divided this checklist into these, 6 and 7 major areas of test cases. And I'm actually going to talk about all of these test cases into this webinar. So yeah, keep listening. I don't think you can get past data without sudo access. Yeah. So that's what I also think, Devang. Uh, Look for exposed framework solutions. HTTP toolkit is a good alternative to burp that can bypass SSL pinning by simulating a VPN. Yes. Yes, totally. Exposed framework can also work for bypassing SSL pinning. I will also cover multiple other solutions which we can use to bypass SSL pinning in the given slides. APK MITM works in some apps, but you can't skip Frida. Okay. You can use edit the smalley code and remove SSL pinning code. Yes. This is also something which can be done. It's called smalley patching. I'll also cover this in resilience. What are the ways to capture an application's request in burp if it has SSL pinning configured properly? We'll have to bypass the SSL pinning, and then only we'll be able to capture the application's API calls. Okay, I think we are done with the questions for now. So moving forward with auth here, testing for confirmed credentials. So we need to validate the duration of time in seconds for which the key is authorized to be used after the user has successfully authenticated. And this is only needed if set authentication required is used. Set authentication required is again a particular method which is present in Android. So you can check about this method also. And if this is being used, you need to just check whether the duration in seconds for which the key has been authorized, how for how long this particular key is valid, and whether it remains valid for a long period of time. So this is basically a very small test case for auth. But yeah, this is basically for the confirmed credentials which we keep when we are authenticating into the application, like pin and things like that. So this is platform specific, but there are again other authorization and authentication related test cases which are covered in the API test cases. So I think we have like a huge audience of bug bounty people over here, and they'll be aware of the authentication test cases as well, right? Through the API calls. Uh, okay, a few more things on chat. Cool, cool. Okay, so moving forward, let's talk about network. So we've spoken about three very small areas, like we've spoken about storage, crypto, and auth. Now let's move forward with network. So with network, we also have a few test cases like data encryption on the network. So we need to check the network security configuration file. And I've given a screenshot of network security configuration file over here, in which there are two types of configs which we need to check. One is a base config and one is a domain config. And we are looking at clear text traffic permitted to false and clear text traffic permitted to true. So clear text traffic permitted is basically a setting which is helping us identify whether HTTP traffic is either originating or transmitted through the application or not. And this is something which is not recommended, as most of the folks here would already know, because HTTPS is the secure mechanism now, and there is no recommendation for using HTTP because it's vulnerable to multiple kinds of attacks, specifically MITM. So clear text traffic permitted to false for a base config has been done. Base config is basically a config which is config setting which is present by default. A domain config setting is basically a setting which we need to put up by ourselves. And once we have set up a domain config setting, that domain config setting automatically bypasses the base config setting. So even if in the base config setting here it is mentioned that clear text traffic is permitted to false, here if it's mentioned to true in the domain config, it means that clear text traffic can be permitted through this application. This particular network security config file, again, you can find after reverse engineering. Then we also need to look at the TLS settings, that is transportless security settings. And we need to report the usage of TLS version 1.1 and TLS version 1.0 also. Only TLS 1.2 and 1.3 is recommended as a security setting for transportless security. Then performing some kind of performing network analysis. In the static analysis, we are looking at custom trust anchors, verifying the server certificate, WebView server certificate verification, and host name verification. So how are we covering these points in static analysis? First, to check the custom trust anchors, we are looking at the application source code. And in the application source code, again in the network security config, we are checking that in the trust anchors are nothing but the certificates of the application. And we need to ensure that the certificates of the applications are configured properly. For instance, here we can see that the certificates are configured for system and for user as well, right? So this is not the correct configuration, because we need to ensure that all of these certificates are not, all of the trust anchors are not included any certificates from the user's end. Because if that happens, then any user, any end user who has the application has been installed on the client end, and it's very easy for anyone to extract the APK out of that application. Once you have the APK, you can also create a signature for that APK. And once you've created that signature, you can sign it and you can again run it. And if after running that application is able to, connect to the servers at the backend and is able to provide you with data, it means that it's working on a user signed certificate, which should not relatively be the case. So these are the settings which will actually point you towards what is the test case you need to check dynamically. So it is very important to perform a static analysis in mobile applications, because they're actually pointing you towards something which you can take leverage of when you are dynamically performing an assessment on an application. So checking of trust anchors is important. Then verifying the server certificate, again the same thing which I mentioned, that whether the server certificate verification settings, how are they included into the source code, whether the verification is done properly or not. Whether if the certificate is not correct, what is the response which is being sent from the application, that okay, the certificate is not correct, but it's still connecting you with that HTTP, with the connection. So this is not supposed to be the correct implementation. Then we have webview server certificate verification. Again, this particular setting you can check into the source code. And hostname verification, how is the hostname getting verified, whether the certificate associated with our hostname is only being used in the application, or any hostname certificate is being used within the application, and the users are still able to get the responses from the backend. So these are the things which we can look at through static. And on the dynamic end here, what we can do is that, again, creating a self-signed certificate. How can we create a self-signed certificate? I have given a command to sign a certificate with the help of a key tool over here. So you can use this particular tool. You can also use a jar signer. Nowadays, key tool is being used, and you can install these packages, and they are like openly available to everybody. Keystore is creating like a key store in a .jks format, and you need to upload an alias also. And after that, you have a file in a .pem format, certificate file in a .pem format. You can sign it, and you'll be able to sign your particular APK. Then accepting certificates with an untrusted CA and accepting incorrect host names. Or how are we performing the dynamic analysis for this? Through these processes: custom certificate stores and certificate pinning. So the code which I have given over here is basically a smally code. Now the one thing because of which I really like JADX is that it's not only, after reverse engineering, it's not only showing us the high level language code of an application, but it's also showing us the assembly language code of the application side by side. So we can compare the high level language code with the assembly language code, and we can check whether there are some similarities, or whether it's just a starting point for somebody who doesn't understand assembly code to just gather a few bits from the high level language code and compare it and see, okay, this is what it means. For example, method public check server trusted. So this is clearly showing us that this is a method, and it is a public method, and the name of the method is check server trusted. And then we have like an array length, and we have a few registers v1 v2, and then we have a return type value. So this is basically the assembly language code. And what we can do is that in the dynamic analysis, we can use universal FRIDA scripts, objection, and smally patching in order to just perform an SSL pinning bypass. An SSL pinning bypass is basically bypassing the custom certificate which has been pinned to that application. And how can we do that? With the help of method hooking. We saw that this check server trusted is basically a method which is basically pinning the certificate into the application. And we are just going to find the value which is being returned in a method which is actually checking whether the certificate which has been pinned to the application is the correct certificate or not. And once we are able to find that method, we can just create a script again in JavaScript. A universal FRIDA script is also available on frida.codeshare, but that universal script doesn't always work with real world application. Why that is because the whitelisting for those kind of processes which are being used is already applied on the applications, so that if that process is running in the device, then the application will not work on the device. So this is one mitigation which I have mentioned for SSL pinning, that you need to perform some kind of whitelisting on the processes which are being run on the device, and you need to check that. So if a process named FRIDA or Magisk or Expose is being used in the device, then that application will not work on the device. And then there is also a root detection check which people apply. But yeah, if that is the case, then you can create your custom FRIDA script. don't use a universal one. Just take the universal one as a reference. If you don't know how to write that particular script, you can use it as a reference, and then take it up, check the method at the backend, uh, pick up the method, pick up the variable, and try to inject that script at runtime and see whether you are able to change the value of that return variable at runtime. The same thing we can do through objection also. Objection is another tool which is openly available. You can download it from Google. I am not sure whether Hacktricks has it or not. I think Hacktricks does have the commands related to objection. So you can check those out as well. Objection is also doing the same thing. It is performing method hooking, but it's relatively easier to do it with objection, because objection is just giving you commands to check Android hooking, and you can watch the classes also. You can watch the flow of values in the variables to objection also. So objection, once you call, it will again use the universal frida script by default. But if you want to inject a specific script, then you'll have to use frida. And smally patching, again, you make changes, as somebody mentioned in the chat before also. In smally patching, if on the register itself, like we are looking at registers v1 v2 over here, these are not returning the value right now, so this is just a basic snippet for a smally code. But I don't think we are looking at the method which is actually returning the value, which is providing the decision whether the smally patching has been done correctly or not. So if we are able to make changes in that particular variable, which is returning a Boolean value of true or false, then that we can do through smally patching instead of zero. For example, if you're looking at 0x0 over here, so that means it is uh, false over here, and once we need to make it to true, it's 0x1. So you can just put it on 0x1, repackage your application, recompile your application, sign it, and try to run it. If your smally patched application is working, it means that you have successfully bypassed the SSL bidding. You can check it by uh, proxying the traffic through proxy servers. Okay, so this is about the controls which we need to check on the network end. And the chat is filled with a lot of things.
Correct. So, one question I guess you probably can answer with, which Keyur asked like a couple of minutes back was, hey Naina, have you come across with error like below when you are running ABD root command? ABD cannot run as root in production build. Any solutions for that?
Yeah, I have come across this particular problem. So if you are trying to, what you can do is that if you want to resolve this error right away, just perform ADB shell, and after getting into the shell, write sudo su. It will work. If you're trying to get sudo access without getting into the shell, then it will not work in this particular case. This is basically related to the way the device was rooted. So either what you can do is that you can root your device again, and if you don't want to root your device again, what you can do is that you can just type adb shell, and after getting into the shell, just type the sudo su command, and you will be able to get the sudo access.
Got it. And yeah, I guess Hitesh has one of the major questions is he's getting some
Mhm.
issues while he is setting up the Bob certifications in the system cert. And he's saying that I use IP tables for hooking up the application traffic. IP table enables the whole Android traffic. But when I work on apps which detect root, I get stuck. I use root bypass, Frida pre-built scripts, but sometimes they work. But again, the traffic doesn't show up in the Bob then. Do you have probably a
Right. If the traffic is not showing up, it means that the bypass has not been done properly. So for that, as I mentioned early on, that the universal Frida scripts or universal scripts which are available don't always work in real world applications, because the implementations have also been advanced, because obviously the software engineers are also aware that these kind of vulnerabilities are existing, so they are actively applying patches on those. So in order to bypass this kind of implementation, you will kind of have to perform a, you will have to create a custom FRIDA script. And this custom FRIDA script will be done on a per application basis, because every application has a different implementation. So what you're supposed to do is that, again, you're supposed to reverse engineer. After reverse engineering, you're supposed to check that what is the correct implementation done over here, what are the different methods this is being checking for, and then for all the methods you have to add a bypass in your custom script and then inject that script into the application at runtime. It's basically trial and error. You'll have to keep trying. Hopefully you're able to bypass.
Perfect. Suresh is asking how to capture traffic of a proxy unaware application.
uh, could you explain this question a little?
Suresh, I guess you can give us more details.
Yeah, what do you mean by a proxy unaware application? uh, I think what he's trying to say is that he might have tried to capture the traffic, like frameworks like Flutter, some Flutter app. Okay, okay. I don't think, yeah, but I don't think there is any difference if you want to capture the traffic over here. But one thing which I used to do early on was use HTTP canary. HTTP canary is basically another, I don't know if it's available, and I don't know if it's available anymore or not. But HTTP canary, what it used to do was for frameworks like these, agar like kisi Flutter pe bani hai application, so for these kind of frameworks, it was I was able to proxy traffic through it. So this was basically an application which I used to install on my router device. And once I installed that application on my router device, I just used to add the particular package name, or I could just, it had access to all the applications which are there on the device. So I could select a specific package name, and on that package name, I used to just select that package name and traverse through the application and see whether any traffic is getting captured or not. You can really try HTTP Canary. I think it works on Flutter. Uh, okay, right. I don't want my app to be worked or run in a rooted device. Yeah. Yes, Bimal, there is a fix if you don't want your app to be run on a rooted device. And the fix is that you will have to apply multiple custom checks for all of the processes, which can be used to perform method hooking on an application. You will also have to implement play integrity API, which is basically checking the integrity of the device on which the application has been installed. I will also talk about play integrity API in the later slides, so you can tune in to listen to that as well. HTTP Canary was down for a long time, but it is back on Play Store. Yeah, it was down for a long time, and I was also actually worried because I used to use it like a few years back. Okay, somebody is saying it's not in work with Flutter. I have worked with a couple of applications with which it works, but yeah, I think I'll have to uh, get back to you with a little bit of research for this. Uh, Proxyfire is an alternative. Okay. Okay. So I think we can move ahead.
Yeah.
Okay. So coming back to our test cases, and let's talk about platform specific test cases, which is mostly the most interesting part of this. So sensitive data which is exposed through IPC mechanism, as I have mentioned, there are a lot of intra-process communication which is taking place, and this inter-process communication is mainly taking place with the help of components which are present into the application. So the first component which I have mentioned over here is exported provider. Uh, but for particular inter-process communication, I'll be specifically mentioning about exported components and yeah, deep link misconfigurations. Okay, cool. So talking about exported providers. So again, content providers are basically, something which is storing your data into the application sandbox. So all the applications in an Android device are basically or basically have an application sandbox. And this application sandbox is something which is preventing other applications which are installed on your device to see what data is being stored by application A. So there are two applications, let's say three applications, ABC. Application A has its own sandbox, B has its own sandbox, and C has its own sandbox. Now if B wants to look at the what is the data which is being stored by A, B will not be able to do that. And if B wants to see what is the data which is being stored by C, B will not be able to do that. But if A really wants B to look at the data, then it will have to provide some specific conditions, specific permissions to the content providers in order for B to access that data in A's application sandbox. And this is where problems occur. So I've taken an example of a content provider over here, and the name of this provider is GB Content Provider. Again, through static analysis, I was able to check this. Again, it is mentioned in the manifest.xml, and I'm seeing that the exported to true has been enabled for this particular content provider. But as you can see over here, except the path permission, any uses permission tag is not included. So the mitigation over here is inclusion of a uses permission tag. And in that uses permission tag, you are explicitly supposed to mention the package name in order to ensure that only the application to which you want to share the data of that content. For a dynamic analysis over here, there is the usage of a tool called Droser. So Droser is also an interesting tool which we can use to perform all of these attacks on the application components. We can also do the same through ADB also. If we want to invoke any components through Activity Manager, the command goes by ADB AM. AM stands for Activity Manager. So from there also we can invoke a few things, but Droser also works very nicely. So I've given a command over here, which is basically running an app.provider.query. And in the content, I'm actually, in the content schema, I'm mentioning the name of the content provider. And I have added another directory called passwords. Now, and there is also a version ID over here, that is 1. So once we run this command, we are able to see that the name of the service, the username, the password, and all of these details, also an email ID, which is being displayed over here. So we are able to basically query the content of this content provider. Why are we able to do that? Because the exported tag has been set to true and proper conditions or proper permissions have not been set. So once you're able to retrieve that information, again, it's a data disclosure. But SQL injection can also be performed on this particular content provider. Again, we can do this through Droser. Multiple commands available. You can check blog posts across the internet. It's everywhere. So SQL injection, how can we do? By manipulating the projection and selection fields which are passed to the content provider. So here projection and selection fields are nothing but the number of projection stands for columns, which we are trying to query, and selection is for rows, which we are trying to query. So this is the scanner.provider.injection. This is basically the command which is again provided by Droser. And in this, we are basically mentioning the package name of the application. And what we are doing is that for this package name, we are just checking through Droser whether any type of injection attack is possible on this particular package name or not. And in the result, we are able to see that it's giving us the schema of content providers, and it's also giving us the directories of that content provider. And it is giving us this detail for both projection and selection. And once we are able to get this detail, we can just manipulate the data which is there in this keys and passwords and all of these directories. And another example which I have given over here is that of an ADB shell. So as I mentioned earlier on, through ADB shell also we can query the contents of a content provider. And the query goes like this. We just have to content query, and in the URI we are just supposed to mention the content provider schema. And in the schema, it's giving us row 1 and ID 1 and ID 2, and it's giving us details regarding the username and password. And this is something which we can use to perform any kind of manipulation, or also use this to chain another attack on the application. So availability of browser is something which is also important, and is a test case which should definitely be considered. Moving forward, another exported component which we can talk about is an activity. So again, I've given, for attacking the exported components, I have given 3 ways over here. Number one is you can do it through activity manager. You can directly say am start and mention the package name. And after creating like a slash, you can mention the activity name also. Through browser, this is the command which you can use, and through adb, this is the command which you can use. And you can also, if you want, you can also check the attack surface of a particular application through browser, and this you can do by specifically running the command app.package.attack surface. You can mention the package name over here, and it will tell you how many activities broadcast receivers or content provider of a particular application are exported. And you can then you can manually go for all of the activities or broadcast receivers or content providers and manually go and check whether you are able to, get data out of any of these components, or you are able to perform any kind of attacks on these components. So impact in this case, let's say there is an activity which is exported and it's a post authentication activity, right? So once you're able to start this activity externally, it means that you're able to start a post authentication activity by yourself externally, and you don't even require any kind of authentication to start that activity because it is exported. So that's kind of an authentication bypass. So all of these test cases are actually intermingled, as I mentioned early on. So yeah, this is something which needs to be focused on as well. Okay, again, we have like a few things on the chat. Manually the offset. This method, okay. Cool. So, okay. We don't have any questions regarding this. So moving forward, then we have app permissions. So a dump sys command, you can use it through ADB shell, and in that dump sys command, you can mention the package name. And in the package name, all of the declared permissions, whether they are dangerous permissions or signature permissions or custom permissions, you'll be able to see uh, all of the permissions which are being asked by the application. So through the dump sys command, you can just verify. And what you can do is that you can go back to the concerned teams if you're working with the teams, and you can ask them whether there is like for example, there is this particular permission called use credentials and it is granted to true. And then there is YouTube permission cd2 message. This is basically a signature permission, so this is not that important. But yeah, use credentials permission, so you can basically go back to your teams and ask them what is the use of this kind of permission. And if it is not being used, then it should definitely be removed. Why? Because these are some permissions which are actually related to the user's privacy, and we need to ensure that any kind of application which we are developing or we are helping in the development process, we need to ensure that it is not taking anything away from the user. It is ensuring that the privacy of the user or any kind of details from the user, like their contact details or their message details, any kind of message which is being received by the user, is not actually permitted by the application to see. Because let's say the application has the permission to look at OTP and things like that. So yeah, that is a relative permission, and it's a business use case which is being asked by the applications. So there we can't do anything about it, and we need to provide an exception. Then but then we also need to ensure that the way in which that OTP mechanism has been set up is secure and it is not related to vulnerabilities. So you can ensure that all of the test cases in the API calls regarding that have been properly analyzed. So this is regarding app permissions. And then we have deep link misconfigurations. So deep links are nothing but a type of links which are sending a user directly into the application instead of a website or a store. They are used to send users straight to specific in-app locations, saving the user's time and energy locating a particular page themselves. For example, if you want to create a payment, and no matter what kind of payment app you're using, there's like one message or one notification which you receive, and once you click on it, it's actually directing you straight to the payment activity, obviously ensuring that you're authenticating in a proper way, and straight to the payment activity. So that is basically the implementation of a deep link which has taken place there. And implementing a deep link also ensures that all of these intents which are being used in the background are passing some kind of data which is essential for performing that particular action. So we need to ensure that we are able to see everything which is going on in the background. So in static, what we can do is that for checking the deep link usage, we there is this Android app link verification tester, which is again provided by Google to us. So this is something which you can use, and it is basically a script which is used to list all the deep links into the app, which are being used by the application using the list all command. So you can check this out over here. I've linked it here. And for website association, again, yeah, you can check it through ADB. And PM stands for package manager. So ADB package manager command you can run. And excuse me, for getting all the app links, you can just mention the package name over there. So once you mention the package name, it will also give you, it will not only give you details regarding what are the links which are being used by that package, but it will also give you details regarding what is the website with which this particular deep link is associated with. So this is something, this is also something which you can look at from a security engineer's perspective, that whether all of this data is properly being displayed or not. And if you see that some different website association is coming up over there, then you can definitely move forward to whether you can chain it with some other kind of attack or not. Checking for subdomains. Subdomains can easily be checked through manifest.xml. And checking the handler method, something very important. Handler method, which is basically handling the URL of a deep link, the hostname validation, and whitelisting. So mainly all of the issues which occur because of the deep links are actually because of the absence of proper URL validation and hostname validation and whitelisting. So this is also something which needs to be considered. For example, here I have given you a snippet of this webview activity, and this webview activity is basically passing a deep link. So what it's doing is that, if you can see in the URI type, there is a variable called data2, and this data2 is basically getting an intent, and it is also calling a method called get data. So this intent is getting some data, and that is being stored in data2. And in the deep link URL, this data2 is getting transmitted. So the only thing which is being checked in this method is whether this deep link URL is null or not. And if it's not null, it is just getting loaded inside the web view. So this is an incorrect implementation, because we also need to check what is the data which is being transmitted through that deep link, whether that data and provide perfect sanitization on that data, right? Whether it is falling into the expected standard of the data which is being expected by the application or not. And there is also no validation which is applied on the URL which is being received from the deep link and the hostname which is being received from the deep link. So it is supposed to be ensured that all of this is checked before this particular deep link is loaded in the web view. Because if we are not doing that, then any kind of attacker who is able to perform some kind of social engineering and just deliver the URL to an end user. Let's say, let's take an example of an application A, and that application is using some deep links to display data to their users in their own web view. Everybody is aware of the concept of web view, where in the application itself, the web view can open and you can access data there. It will not move your data, it will not move your browsing to the browser. Sometimes that also happens, but most of the applications are using this mechanism of including the web view into the application itself. So if you are loading this data into your web view, and application is able to load data into their web view, and to the victim user, the attacker is able to just deliver a payload through social engineering. And in that payload, they have mentioned the deep link which is being used by that application, because they were able to check all of the deep links which are associated to that application through list all deep links. So you just create like a deep link, and in that you can perform any kind of open redirection and redirect it to your attacker controlled environment. And if it is also working in the background, it's working with an intent which is getting some kind of data, if the victim user is clicking on that link, it will open it on their device on that application which is serving the web view, and all of those that data which is related to that particular deep link. It can be session details, it can be any kind of data which is being transmitted. It will be sent directly to the attacker controlled environment, because in the deep link they have crafted it so maliciously that they have open redirected it to an attacker control domain. So that is something which can also occur. That's why it's essential to ensure the data which is being passed, the URL validation and the host name validation, something which I keep on reiterating again and again for preventing deep link misconfiguration. On the dynamic end, so we can perform FRIDA hooking here, and then perform an invocation of the deep link. So what are we doing over here? Again, there is this script called Android Deep Link Observer from FRIDA, available on CodeShare. And what this can be used for, it can be used to monitor all of the invoked deep links, triggering a call to the intent.getData. Again and again, I keep talking about intent.getData because that is the most important component over here. If I've not mentioned before, intent is nothing but a component of the Android application, which is basically used to perform communication within other components of the application. Let's say there's an activity, service, broadcast, receiver, content provider. So there's an activity, and that activity is actually directing you to some other activity, right? So you'll have to click some or the other button on the application in order to get directed to that activity, right? So once you clicked on that button, an intent will get triggered, and that intent will direct the application and tell them that the meaning of this particular click from the user is that they want to direct themselves to the other activity of this application. So this is, I'm just telling you the background behind how an intent is working. So in hindsight, talking about deep link, again, the formation of intent remains the same. So again, there are two types of intents, explicit and implicit intents. And so the intents which are created within the application, transmitting the user within the application, are called explicit intents, but implicit intents are the ones which are transmitting the user from other application also. Okay. So again, the same way it works with the deep links also, there are implicit and explicit deep links, again related to the intents over here. So what this particular script is doing, we have just set up the script through FRIDA to monitor all of the deep links which are triggering a call to intent.getData. And after that, what we'll do one by one is that invoke these deep links. How can we invoke them? Through Activity Manager, again through ADB shell. We are just mentioning the intent, and we are mentioning the action of the intent, and that is to view. And -d, we are mentioning the deep link name over here. Once we have mentioned the deep link name, you will see that it's starting an intent, and it will show you some data, and ultimately it will show you the data, including the scheme, the host, the parameters which are being passed. So in this case, the only one parameter is being passed, and that is a message called OK. But in sensitive cases, some other parameters will also get passed, and sometimes it will also be able to display SSO token and other authentication tokens of the user over here. So if that happens, again, SSO token you can pick up and log into any user's session. So this is something which is an interesting finding for all of the Android related vulnerabilities. So I would advise you guys to definitely check this out the next time you are performing an assessment on an Android application. Okay. Hitesh is asking that is there a way that we can get API calls which can be made by an Android application without hooking it up with Burp just by static analysis? Yeah, as Devang has mentioned, it will be very tedious. You can regex and grep, but yeah, it's going to be very tedious. So short answer is, if you want to perform assessment properly, then no. Okay. Okay, can you explain a little bit more on the SSO tokens in data? Okay, so let's say the deep link is triggered, And that deep link is basically, used to, how do I put this? Okay, let's say there's an application A and that there's another embedded service, which that application is using with third party B. Okay. Now, any kind of deep link calls which are going through application A sometimes might be able to, you know, include an SSO token in those calls. So once that SSO token is included in those calls, and you have, set up the script of looking at the deep link observer and started invoking the deep links one by one while the application is running, right? So once you invoke, you will be able to see that data over here. And let's say if in the parameters it includes the SSO token, then in multiple ways, using the API calls, you can use that particular SSO token to authenticate into the user's session. That was basically the short explanation which I was going for. But the crux of the matter there was that in the parameters, any kind of data can be disclosed, and then you can use that data which is disclosed to chain to other attacks. Okay. Moving forward with another platform misconfiguration, that is webview misconfiguration. So if JavaScript is basically disabled by default in a web view, then it's not a problem. But if JavaScript is, let's say, enabled in the web view, then JavaScript is again set to get executed in the web view, right? So for WebView configuration, multiple things you need to check. Whenever you are looking at manifest.xml, you need to find out what kind of activities are actually using the WebView in the application. And once you're able to find out what applications are using WebView, you can just traverse to those applications and check what are the permissions which they are allowing. For example, access to content providers, set allow content access. So the default value for this is true. That is sorry, the set allow content access default value is true, that is enabled by default, right? So this is a problem, and if you don't want to allow access to content providers through the web view, you need to ensure that this is explicitly set to false. Then set allow file access, again starting Android 11, default value has been turned to false, which is a good thing. This is disabled by default, so you don't have to explicitly disable it. And then we have access to local files from external sources. This is the most important setting, and this has two settings involved in this. Number one is set allow file access from file URLs, and the default value is false, that is, it is disabled by default. And set allow universal access from file URLs, default value is false, again disabled by default. But the meaning of these settings is that, let's say, set allow universal access from file URLs. If by including just the file schema, somebody is able to find out that this particular file is stored in this location into the device, they'll be able to universally access those files from just the file URL, because the web view has been enabled. And in that web view, this particular setting, set allow universal access from file URL, has been enabled. So access to local files would be able to be possible from external sources with the help of this setting. So it is of utmost important for users for the software engineers and developers of the application to ensure that these settings are not enabled unless there is an explicit use case which is defining the business case of that application. So again, in WebView, misconfigurations can occur in two ways. Number one is through malicious web pages, and number two is through malicious applications. So what does this mean? Let's say there's a victim Android application, and there is a web view in that application, and there is a malicious web page. Now, there is some native Java code which is binding to the Java objects. So in the web view, if a malicious web page is getting opened, that means that it is infecting all of the users who are able to open that particular malicious web page in the web view of that application. And number two is through malicious applications, where malicious native Java code is actually communicating with the web view of the application. Let's say there is a malicious Android application, it has a web view and it has a web page. And the system code is basically communicating with that victim web page which is getting hosted on the malicious Android application. So that will impact again all of the users of that malicious application. So both the ways it can be used. It can be a malicious web page also, and it can be a malicious Android application also, which is hosting a web page. Right. So these are the misconfigurations which are related to WebView. So for platform, until now, we have covered some important but multiple things like exported content providers, that is sensitive data which is getting exposed through IPC mechanism, interprocess communication mechanisms. That can be through exported components, let's say activities. Then it can be because of deep link misconfigurations, because of WebView misconfigurations, exported providers, and things like that. And then what are the permissions which are being given to the application, and whether it requires those permissions or not. Okay, so moving forward with the last part of our test cases over here, and that is checking the resilience of the application. So this includes again multiple checks like SSL pinning bypass, root detection bypass, play integrity bypass, performing application tampering, and obfuscation. So here I've just given you an example of objection. Objection is a tool which I mentioned early on. And from objection on the package name, we can just, check and explore for multiple, classes and methods. And we can perform hooking on those classes and methods if they are, perform, according to the test case which we want to check. Let's say if we want to perform SSL pinning bypass, as I already mentioned, we need to check for which are the methods which are actually checking for SSL pinning, whether the mechanism has been correct or not, and then trying to modify the values of those at runtime. The same we'll do for root detection bypass also, exactly the same. For play integrity bypass, however, we need to make a few changes. And yeah, this script is for root detection bypass. Again, this is the command which we use, package name, and this is a sample example of the how the script for root detection bypass with Frida looks like. And we're also logging a few things over here in order to see whether whenever the script is working, what is the status. And we are just returning false there, and again logging after confirmation that the root detection has been bypassed. Again, this is a very, very small and basic example script. The scripts which you will be writing in real world application would be, much more bigger, because the implementation is much more advanced. So you'll have to create much more tweaks, not just one simple tweak, in order to bypass something which is as complicated as root detection. Then we have play integrity bypass. So what is play integrity? So I have given a diagram over here in which there is a Google Play server. In the middle, there is an application, and then there is an application server. So let's say a user is performing an action. The app server, what it will do is that it will start a integrity check, and it will send a unique ID to the application. What the application will do is that application will call the play integrity API, and that will start the play integrity server. On the when it is invoking the play integrity API, it will also include this particular unique ID which was received from the application server. Now the play integrity server will return an integrity verdict, whether the integrity of the device on which this application is running is intact or not. And on the basis of that, the application will return the result to the application server, along with the verdict which it has received from the play integrity server. And from there, the application server will make a decision according to the verdict which it has received from play integrity server. It will pass to the application, and the user will get a result. What this means is that there are three types of integrities which are available in each device. Number one is basic, number two is device, and number two is strong integrity. So for all three kinds of integrities, there are some controls which are attached. And if we are able to bypass, or if we are able to, just perform some kind of tweaks into the integrity of our device on which the application is running, then we can modify the behavior of this play integrity implementation. So here I've attached a very small snippet of Universal Safety Net Fix. This is basically a mod which is provided by Magisk. And if you enable this universal safety net fix, what it does is that it is actually, even if your device is rooted, when your device is rooted, mostly it has all the integrity which is gone. There is no integrity. Basic, strong, device, all three are gone. Now, if you want to enable the integrity, let's say basic and device, you can just enable this universal safety net fix. Again, check whether the integrity of the device is changed or not. And if it has turned to basic and device, and that particular application now you start to run, when it will go to the play server and it will check for the verdict of the device's integrity, it will return that, okay, this device has basic and device integrity intact. And just in case the application is not checking for strong integrity, you will be able to bypass the play integrity. You can also bypass strong integrity. Different kinds of mods are available for it. But yeah, it is difficult to find a mod for strong one. But yeah, people are still able to do that. So this is how play integrity can be bypassed. So this is another form of resilience check. And the last resilience check is application tampering. So application tampering is, this is something which this is, I think, one of my favorite resilient test cases. Root detection and SSL pinning are getting common, but in application tampering, what we are doing is that we are just decompiling the application through APK tool. Right now, when I spoke about all of the reverse engineering, I mostly mentioned the JADX reverse engineering, but we can also do it through APK tool. So, but what APK tool is doing, it is not giving us, all the high level language source code, because it is giving us files in classes.dex format, which I mentioned towards the beginning of this presentation, that all of those files are actually Dalvik executable files. So, what do we do with those? If you are somebody who's able to read assembly language code, you will have all of those classes decoded to Smalley over there. And in Smalley, you will have classes in Smalley, you will have android.manifest.xml, and you will have all the resources. So a small way to tamper the application, whether it is tamperable or not, what you can do is that you can include like a small image or a very small resource into the resources, and then just recompile and sign the application. You just recompile the application to APK tool, sign the application to key tool, and then just try to make that application communicate with the backend server. If that application is communicating with the backend server when you have tampered something, it means that there is some problem in the resilience in terms of application tampering. And in order to confirm this, now in the second test case which you can check, just don't include one image, but also try to tamper some of the code which is there in Smalley. Let's say just change the value of one or two registers from true to false or false to true, just for Boolean values, and see whether you're still able to communicate with the backend. If you're able to do that, then again the resilience has been compromised. So this was all about the resilience checks. So I think we have covered all of the test cases regarding the areas which I mentioned. And mm, yeah, so that's all. If you guys have any questions, then we can move forward.
That was a very detailed session, Anna. Thank you for that. And while I'm seeing, I guess we have answered a lot of questions during the entire presentation itself. But
Right.
if somebody has any last bit of questions that you want us to answer, you want Naina to answer probably, right? And you can post it now. And then probably I can stop the recording and we can wrap up this particular webinar.
Thanks, Chirag. Thanks, Hitesh.
Uh, I guess we'll have it edited in two parts so that people actually have a good retention on that as well.
Right, right. It kind of got stretched. Okay. Somebody is asking, does Android security involve CI/CD? Yes, it definitely does. We, like, in a real world, we are setting up multiple things for CI/CD, on CI/CD for Android security. Like we are setting up all of the source code review, because in a real world the source code is magnanimous, not just. So this is something which a user can, the kind of static analysis which I have mentioned is something which the user can do on their end, and just perform reverse engineering and do it. But for all of the source code, We do need, any source code review tools in the CI/CD. We need tools which are, keeping a track of the API endpoints. And then in the CI/CD, obviously the backend servers which are getting communicated with. We also need to ensure that the configuration of those backend servers has been done properly according to, different benchmarking standards, let's say. So all of these tools also, let's say, like, this is just a huge process which is going in, which is, involving the usage of multiple use cases. So yeah, in short, it does involve CI/CD a little bit. Okay. Thanks everyone. Thanks Anoop. Thanks Tushar. Thanks Kamal.